Hello everyone, welcome back to Everything Mathematics. Today we are about to take a deep dive into the world of tangent and uncover some fascinating identities for the sum and difference of two angles. But before we get started, I am assuming that you are familiar with the identities for the sine and cosine of A plus B. If you're not, don't worry, I've got you covered. I'll link to another video in the description box below that explains those identities. Also, I am assuming that you are aware that tangent is an odd function. That is, tangent of negative A equals negative tangent of A. If you're not sure what that means, no problem. I have another video that explains even in odd functions with sine, cosine, and tangent. You can find that linked in the description box below as well. So now let's get started deriving the identities. We're going to start with the tangent of A plus B. But before we do that, I want you to look at this identity here. We know that tangent of an angle x, any angle, is equal to sine x over cosine x. And we're going to use that right away over here. So I'm going to rewrite this as tangent of A plus B as sine of A plus B divided by the cosine of A plus B. This is pretty much applying this identity to this expression here on the left. Now I have sine of the sum of two angles over cosine of the sum of two angles. And if you remember, just a few minutes ago, I displayed the identities for the sine of A plus B and the cosine of A plus B. So we're going to go ahead now and expand the numerator and denominator by applying those identities. We're going to do it like this. Sine of A plus B is equal to sine A times cosine of B plus sine B times cosine of A. Now, all of this will be divided by cosine of A times cosine of B minus sine of A times the sine of B. So this is pretty much applying the identities. Now, the identity for tangent that we're after will not have cosines and sines at all. The identity will only have tangents and a few constants, but it will not have sine and cosine. So we have to find a way to get rid of sines and cosines in order to get our new identity. In order to do that, we're going to go ahead now and use this result here. Look, here I have a number x, and I am multiplying x by a over a. Same number. This is like having 2 divided by 2, or 3 divided by 3. And a over a is always equal to 1. 3 over 3 is 1. 4 over 4 is 1. So in a sense, x times a over a is like multiplying x times 1. And x times 1 is equal to x. So this will be a nice little trick that we're going to go ahead and apply here. Look at this. I'm going to now multiply the top and the bottom by 1 over cosine A times cosine B. And the same thing over here. 1 over cosine A times cosine B right here. And I want you to notice that this fraction is identical to this fraction. And what we are going to do now is we're going to go ahead and take this and distribute that with the sum that we have on the left. I know that it looks complicated, but try to follow and you'll see. So all this right here will multiply this term and will multiply this term. Similarly, all this right here will multiply this and will multiply this. So what we're going to have now is the following. Look at this. We're going to have sine A times cosine B. This is precisely this term right here. But when you multiply it by this fraction, sine A cosine B will go in the numerator and this will remain in the denominator. So this is what we're going to have. This will be divided by cosine A times cosine B plus. Now we're going to multiply again the same fraction times the second term. So this is going to give us sine B times cosine A, and all this will be divided by cosine A times cosine B. And then all this will be divided by the same way over here. We're going to take this fraction and we're going to multiply it by these two terms. So then this is going to be cosine A times cosine of B divided by cosine A times cosine B. And then finally, we're going to have sine A times sine B, all this divided by cosine A times cosine B. So it looks massive, but now it's going to start simplifying really nicely. Take a look at this. See, here we have cosine B and cosine B below. So then that means that I can very nicely cancel this and this. On the other side, I can cancel cosine A and cosine A. Right here below, I want you to notice that cosine A and cosine B are identical, both on top and below. So they'll cancel out. So that will cancel with cosine A, cosine B, and cosine B. So what we're going to have here in our next steps, this will now simplify to just 1. And now here on this side, there are no common factors, so nothing will cancel. But I want you to notice that this expression here, sine A over cosine A, is tangent A. And sine B over cosine B is tangent B. Now I'm going to go ahead and rewrite the simplified version, the leftover. We have sine A divided by cosine A plus sine B divided by cosine B. In the denominator, if you remember, all of these factors canceled out. So then 1 remains there. 1 minus, nothing was canceled in the second term, sine A over cosine A times sine B over cosine B. And now we're going to be applying this identity that will be tangent of A. So I'm going to write tangent A here plus tangent B divided by 1 minus tangent A times tangent of angle B. And here we end up beautifully with the identity for the tangent of A plus B. Now let's go ahead and derive the identity for the tangent of A minus B. Now, here I have again the identity that we just derived, the tangent of a plus b. And I'm reminding you again what it means for tangent to be odd, because we're going to use both of these results in the derivation of this new identity. Now here we have a minus b, and I want to be able to use this identity, but this is for the sum of two angles. So what I'm going to do is I will re-express this difference in a sum in the following way. I will re-express tangent of a minus b as tangent of a plus negative b. And I really want you to notice that everything is fine, that we can do that. Notice how very nicely a positive times a negative is a negative. So we haven't changed the expression. But now that I have a plus over here, I can think of adding two angles. The first angle remains the same, angle A. The second angle will be negative b. So a plus negative b. And now I'm ready to apply this identity right here. So I'm going to write tangent of my first angle, angle A, plus tangent of my second angle. The second angle is negative b. And all this will be divided by 1 minus tangent of A times tangent of negative b. And notice that now it's time to use the fact that tangent is odd. So for example, since tangent is odd, this negative right here is going to come outside, and it's going to turn this positive into a negative. Here in the bottom, again, the negative will come outside, and it will multiply this negative here. So that will turn into a positive. So then that means that we're going to have tangent of A minus tangent of B, because tangent is an odd function, divided by 1 plus tangent of A times the tangent of B. And here we have the identity for tangent of A minus B. All right, folks, we've just uncovered the hidden secrets behind the tangent of the sum and difference of two angles. By going behind the scenes and breaking down the derivations, we've not only expanded our knowledge of math, but also gained deeper appreciation for the complexity and beauty of these identities. Because remember that mathematics isn't just about memorizing formulas and equations. It's about understanding the reasoning behind them and the significance they hold. So keep exploring and learning, keep practicing. Until next time, friends, bye for now.